This is the final exam review video for Chapter 8, Video 3. So get out your exam review so that you can do some of these with us. The second part of Chapter 8 worked on distributing, or the first part of Chapter 8 worked on distributing and multiplying, and now the second part works on factoring, which is going the opposite direction. You had a graphic, and you can pause the video on this graphic, that we used all the time to decide the order of that we were going to try to factor or turn expressions back into their multiplied form. We always started by looking for a GCF. Then after that, we decided if it had 2 terms, what we would check. If it had 3 terms, what kind of factoring we would check. And if it had 4 terms, what kind of factoring we would check. So if you need to get out your notes or pause the video here and get these ideas onto your note card, that might not be a bad idea, or look for it on your note card from Chapter 8, Part 2. So in the first ones that you see here that I've chosen for this video, number 3 and 4, it says first factor by finding the greatest common factor. We also called that monomial factoring. We're going to find the one expression, numbers and variables, that all the expressions in that can be divided by. So if I look at number 3, numbers-wise, 35 and 20, some of you liked to make factor trees. Some of you liked to do all sorts of things. We need to find their largest factor that they both can be divided by. And so it's got to be 20 or smaller. And the factors of 20 are 20, 1, 10, 5, 4, and 2. And the largest one that's also a factor of 35 is 5. So I'm going to GCF factor a 5 value for that. Then x cubed and x squared both have at least 2 factors of x. So that is my GCF, or monomial factor, that I'm undistributing, if you want to think about it that way. So if 35x cubed were divided by 5x squared, we'd get whatever it takes for 5x squared to multiply by something and make 35x cubed. So 5 times 7, x squared times 1 more x factor, plus. Now we need to think about what would happen so that 5x squared could multiply by something and make 20x squared, and we'd need a 4. So that's our factoring. We turned it from a simplest form expression back into a multiplied expression. When you look at number 4, you also want to be thinking about the greatest common factor for those numerical values, and they will be 12 or smaller. So start with the smallest value and think of its factors. And if you can list them, you don't have to list them in order. You just want to think of the factors of 12 and see which ones of them are also factors of 30 and 60. It has to be common to all of them. 12 is not a common factor to 30, but 6 is. So 6 is the largest of 12's factors that's also in common to the other ones, so 6 will be the numerical part. Then variables-wise, they do not all have an x, so I can't take any x's out. I'll only be able to monomial factor out the 6. So then I want to think about 6 times what to make that 60x squared. Must have been as 10x squared. Plus 6 times what to make 12x? A 2 and an x. Minus 6 times 5 to make the 30. And that would be getting at least the GCF, or greatest factor, out of all of the terms. After you do that on our factoring thing, it says that if there's 4 terms left, we should factor by grouping. So first I want to look through and check my number 5 to see if there are any greatest common factors to all 4 terms, and I don't see any. So the idea of doing factoring by grouping was to take a group of 2 and then take the other group of 2 and handle them separately. So now I'm just going to look at what's highlighted in yellow. So when I factor that group, I notice that the 2 of them have an x squared factor in common, their greatest common factor. And when I factor that out, I'd have x plus 6. And that's for my first group. And now I'm going to switch colors to my second group. And my second group, including the sign, I notice that they have in common a positive 4. And therefore my factor would also be x plus 6 that they have left. What we notice from here is that this isn't factored yet. So my final factoring has to say, what do my 2 groups have in common now? My blue group and my pink group both have a factor of x plus 6. So I'm going to take that, say that's a common factor. And then most of you thought about it as what were the distributors, grouping up the 2 distributors so that we can think of it as x squared has to multiply by x plus 6 and 4. So we put our distributors together in one factor and what that common factor was in the other. So you could pause the video right now, try out number 6. When you get to 8, we were using factoring in order to solve. So the idea was we would factor the expression as long as it was already equal to 0. So we had to check, was our equation equal to 0, or we had to get it that way. Then we had to factor the side that all the terms were on, and then each factor gets set equal to 0. And a lot of you were really successful at finding solutions this way. So in number 8, it already is set equal to 0, but it's not factored on that left-hand side. So I want to go down through my factoring checklist. And in my factoring checklist, I would GCF factor out a 6 and an x. And I would have left behind a 3x and a plus 2. Again, those are not my solutions yet. That's getting it to factored form. Then each factor, so 6x is one of my factors, that will get set equal to 0. And 3x plus 2 is my other factor, which will get set equal to 0. You're going to solve and get what your x values are from each of those as your 2 solutions. Pause the video and finish that one. When you get to number 9, then they're going to put that into a word problem format. A toy rocket is launched upward with an initial velocity of 80 feet per second. The height of the rocket is given in feet, t seconds after it's launched, modeled by this equation. So I've always suggested you move down the equation, and let's be sure we know what each variable stands for so we know what our answers mean. They said that h is the height of the rocket in feet. And that t, both the t's, are time in seconds since it's been launched. Again, take a moment, mark that down. It'll make the rest of the problem much easier. After how many seconds does the rocket return to the ground? We also then made a very rough sketch of what this would look like as far as time and height. Time and height. We know from graphing quadratics already that the y-intercept here is 0. And then we know that it opens upside down because of that negative value. So we know it looks something like this. So it's got to get back down to the ground after so many seconds. It does make sense to us that 0 will be one of our solutions, but we're going for this other one. So in order to do that, we're going to say, well, when is the height 0? Because the height is 0 when the object's on the ground. So this is going to help us find the 2 times that makes the height come out 0. We already know the first one, or can guess the first one 0, but we need that second one. So I'm going to factor to do this. I'm going to look over and see what they have in common, and I know that they're both divisible by 8, and I know that they both have a t. So that would make my factoring negative 2t plus 10. Again, then I'm going to, just like I did above, set each of my factors equal to 0. 8t was one of my factors, and negative 2t plus 10 was my other factor. When I set those equal to 0, this one's going to get me 0. And this one, when you solve it, is going to get me the other time when the rocket was on the ground. So stay and finish that one up. And finally, then using zero product property again, but with some more complicated factoring and some slightly different situations. So let's look at 17, because that's the toughest of the ones here. So in 17, that checklist of things we said has to be equal to 0 first. Well, mine's not. So I'm going to need to add 5x on both sides in order to have this side be 0. All right, so I've got x squared plus 11x plus 28 equals 0. Now it's ready for factoring. There's no GCF. I just checked. GCF other than 1. And it's 3 terms, so I want a diamond factor. All right, so I need things that multiply together to be 28. Some of you like that in the bottom. Some of you guys don't mind that in the top. And I need things that add together to be 11. So remember, they have to multiply to make my C value, but add to make my B value. So I'm thinking 7 and 4. So I'm going to check if my factors could be x plus 7 and x plus 4 equal to 0. And if I did a quick FOIL, that actually works. That is the correct factoring, and you may need to convince yourself of that. And then go ahead and solve. Each factor equal to 0, and get your 2 solutions. And I'm not finishing this one up. That's for you.